Hi, I'm Divyapriya from the Department of Artificial Intelligence and Data Science. Our mini project is crop yield prediction using machine learning. Our team number is 231 under the guidance of Pavai. Agenda: Introduction, statement of the problem, scope of the project, methodology, architectural diagram, flow, algorithm used, design use case diagram, class diagram, implementation, important segments, output, results, test cases, conclusions, future work and references. Introduction. The essential issue in agricultural industry is to predict the crop production. Achieving maximum production of crop yield rate with limited number of resources is the main objective of agricultural planning. Many machine learning algorithms can help in improving the production of crop yield rate. Whenever there is loss in unfavorable conditions, we can apply crop selection method and reduce the losses. Weather conditions like humidity, rainfall, temperature, cloud are also helpful in crop production. Machine learning techniques can be used to improve crop production. Some of the geographical conditions of the region like river ground, hill areas or the depth areas help in crop production. Statement of the problem. Farmers are facing some difficulties in choosing their crop to cultivate. If the farmers chooses one crop instead of another crop, it leads to minimize in farming and maximize in loss. So to overcome this problem, proposed machine learning technique for yield prediction process. Scope of the project. Early and accurate yield predictions help farmers and stakeholders make informed decisions, including resource allocation, crop selection, and financial planning. Optimize use of water, fertilizer, and pesticides. Accurate yield prediction reduce market volatility and help ensure fair pricing for both farmers and consumers. Forecast potential yield loss due to adverse weather or environmental factors. Enable farmers and policymakers to make informed decisions about crop planning, irrigation, fertilization, and pest control, leading to more efficient farming practices and potentially higher crop yields. Methodology: Data collection. Collect data on past crop yields for various crops and regions. Obtain the data on climate factors such as rainfall, temperature, humidity, and sunshine hours. Data pre-processing. Handle missing values, outliers, and inconsistencies in the data. Feature selection. Identify the most relevant features, example temperature, soil type, that significantly impact crop yield. Model selection. Decision tree and random forest support vector machines. Model evaluation. Use mean absolute error. It measures the average magnitude of errors. Then use root mean squared error, sensitive to large errors, useful for identifying significant prediction gaps. Deployment. Deploy the best performing model into the user friendly application or API that stakeholders can access. This is the flowchart of our mini project. Crop data, weather data, apply machine learning algorithm, weather-wise crop data, use GA optimization technique, predict crop. Design use case diagram. The use case model defines the outside and inside of the system behavior. This is the UML diagram of the use case. Class diagram. Class is the representation of the object, and in many ways it is simply a template from which objects are created. Classes form the main building blocks of an object-oriented application. Data store, gathering the soil parameters, gathering the crop parameters, list of crops, input from farmers, acquiring input from farmers, mapping of data. Sequence diagram, user interface trained model database. Algorithms used: linear regression, support vector machines, artificial neural network, k nearest neighbor decision trees. Hardware and software selection, hardware requirement, processor, memory 8 GB. Software requirements, operating system, programming language, Python, libraries and frameworks, NumPy, Pandas, Matplotlib, Seaborn. Implementation, installation of required libraries, import libraries, then load the dataset, then define features and target variable, finally evaluate. It calculates the model performance metrics using mean absolute error, mean squared error. Important code segments. So first we have to import the libraries such as pandas, numpy, seaborn, matplotlib.pyplot. Then load the dataset, then give the command df.head. It will give the overall data inside the dataset. Then df.info, it will give the information about the dataset. These are the important code segments used for this project. From sklearn.preprocessing, import one hot encoder. Then from sklearn.compose, import column transformer. From sklearn.preprocessing, import standard scalar. Then import linear regression, k neighbors, decision tree regressor, mean absolute error or to score. Include the training set and testing set. So this is the output we got in this project. This is the home page. This includes crop yield prediction per country. Input all features here. It has year, average rainfall, pesticides, average temperature, area item. Then predict. Test cases. Test case 1. Upload the input text and we uploaded the result. We got as expected. Results: machine learning accuracy 90%, precision 93%, recall 92%, inference effective prediction, fast diagnosis. Future work. In conclusion, this crop yield prediction project successfully demonstrates the potential of machine learning models to forecast agricultural productivity with significant accuracy. By analyzing historical data on various factors such as weather, soil properties, crop types, and other relevant environmental conditions, we were able to develop a model that can assist farmers, policymakers, and agricultural business in making informed decisions. Results indicate that machine learning can provide valuable insights, enabling better resource allocation, risk management, and strategic planning for future crop cycles. With further optimization, such as integrating real time data and refining the model for specific regional characteristics, this approach could contribute meaningfully to sustainable agricultural practices. In future work, crop yield prediction models could be further improved by integrating more diverse and high resolution data sources such as satellite imagery, advanced climate models, and real time soil data. References: book reference K.F. Victor and Isaac Michael, Intelligent Data Analysis and Machine Learning. Are they really equivalent concepts? In 2017, Second Russia and Pacific Conference on Computer Technology and Application. Thank you.